here's the thing that most people seem to miss. We are all involved in developing products that generate, manage, and consume electromagnetic field energy. This is not electrons moving from someplace. This is electromagnetic field. It's completely different. So when you turn on a switch, circuit theory assumes that current starts flowing in a loop. That's not even close to right. When you turn on a switch, you've added an empty space or a space with a different field density than the space that's on the other side of the switch. So you have one conductor that's not broken, which should be ground. You have a space that's adjacent to that conductor, which is your dielectric, and then you have a switched conductor that takes energy that's stored on this side of the switch, and when the switch turns on, it allows that energy to flow into the new space. And how fast that switch turns on determines what type of structure you need on the output side of that switch for this new space in order to make it so that you have good signal integrity and don't have radiant emissions problems. So it takes time. When the switch is turned on, the field moving into that space has no idea what's at the other end. If what we were taught was true, there would not be problems with signal integrity or with EMC. Because when you turn on the switch, it's like a belt, the loop starts moving energy. That's not the way it works. The energy will now serially flow into this new space, has no idea what's at the other end. Every time you turn on a switch, as far as the switch knows, it's a short circuit because that space through that switch is going to let as much energy flow into this new space as it possibly can until finally something else happens. And we'll talk about that whole process in a few minutes. But the idea is the energy moves into the space and it takes some time for it to get to wherever it's going and then for the field as it's moving into the space to finally come to equilibrium where you have the same field density on both sides of the switch.